create an assembly model, we must start with the part that we're going to build on. So for the assembly that we were doing in class, we started with the bracket. So the first thing we need to do is to import a part. Actually, we want to create the assembly first. So we start with our part, and we're going to click on File, and then Make Assembly from Part. And in SolidWorks, it's going to make the front, top, and right plane with the front, top, and right planes of the assembly file. So we're going to go ahead and click on the check mark to accept this. Now this is our first part in our assembly, and it is fixed. It can't move. We want that. And every additional part that we bring in will be able to move in we'll have 6 degrees of freedom, meaning that it can move in the X, Y, and Z translation, and it can also move in the X, Y, and Z in rotation about those axes. Okay, so we're going to bring in our first component. We go up to Insert Components, Insert Components, and I want you to find the yoke male, and that is, so we're going to click on Browse, and then we want to find the yoke male and click on Open. Okay, so this is our first part, and you'll notice that that part can move in X, Y, and Z. If you right click on the mouse, we can move in rotation X, Y, and Z. We can also do small adjustments, but they're just visual. If you right click on the part and select Move with Triad, and then you'll have X translation, Y, and Z. X, Y, and Z, and then we can also rotate around those axes. Okay, so right click your mouse or right click on the part and click on Move Triad to move your part around. Okay, so how we build assemblies is we add mates, and we want to think about form, fit, and function. How do we want our assembly to work? If it's a table, we want all the parts fixed and not moving. But in this case, we're building a differential, so we do want some components to move, and others are restricted. So we're going to begin by placing this yoke male inside of our bracket. Okay, so we're making a differential. So we begin by, under the Assemblies tab, we're going to click on Mate. Okay, and then we select the faces that we want to add mates to, and then SolidWorks will come up with a mate recommendation. So our very first mate that we're going to learn is concentric mate. So we're going to pick this cylinder, and we're going to pick the inside hole, and SolidWorks automatically adds the concentric mate. It's sharing the axis of the cylinder and the axis of the hole, and that's what's mated. So I'm going to go ahead and click the check mark, and then the part, all it is just a concentric mate. It really doesn't know that the bracket is there. All it sees is the actual mate. Okay, but I want this in the hole, and I do want to restrict its motion. So I want to mate this surface with that surface, and they share a common surface, and that's called a coincident mate. Okay, so I pick this face, rotate my part, or my assembly, and pick the top face of the yoke male. And now I have a coincident mate. And this is the function of my part. I want it to rotate, and I want it inserted in my bracket. Okay. The next thing we're going to do is we're going to bring in another part. So go ahead and close the mate by clicking the check mark. And we want to bring in a new part. Well, I could go back up to Insert Components to bring a new part in. But I want to show you that there's some different ways that we can do this. So between the Control and the Alt key on your keyboard is the Windows key, Microsoft Windows key. So hold the Windows key down and the letter E on your keyboard, and that brings up the File Manager. So locate the spider. So you've downloaded, it's assumed that you downloaded all of your parts from BBLearn. And so mine happens to be in a folder called Assembly X. And I want to find the spider. And once you find the part that you want, all you have to do is take the part, drag it into the screen, and it's there. Sorry, that's not the spider. Here's the spider. Okay. And I'm going to close this. Okay. Now the spider goes right in the center of my yoke mail. It's important that it's exactly in the center, and it's important that these two holes line up. So I'm going to add another concentric mate. Okay, so I'm going to go up to where under the assembly tab, I'm going to click on mate, and then I'm going to select the inside hole of the spider and the inside hole of the yoke mail. And now I have a concentric mate, so that's important. Okay. I want this spider to be on the inside of the yoke mail, and he needs to be exactly in the center. And there's different ways that I could do this. To force it to be in the center, I could calculate the distance between these two, the width of this two, subtract that from that distance, and then divide it by 2, and then do an offset mate. But there's a lot easier way, and that's called the width mate. It actually finds the exact center. Okay, so these are called your standard mates. The width mate is under what's called the advanced mates. It's just how they're grouped. So click on the advanced mates and mates, and you find the width mate is here. So go ahead and click on the width mate. Now the width mate, they have a width selection and a tab selection. It really doesn't matter which one you call the tab or the width. You just need to be consistent. So you have to pick 2 surfaces to calculate the center. Then you go to the next 2 surfaces that you're interested in and calculate the center. So I'm going to select the spider first, pick that face, and this face. It's figured out where the center is. Now I'm going to go to my yoke mail. I'm going to pick that face and this face. And after I select it, it will put the spider exactly in the middle of my yoke. And that's what I want. Okay, and then click the check mark. And the check mark again. So now I have my spider inside of my mail yoke. And this is important, how we translate rotation in one direction to rotation and torque in another direction is by using the spider. That's how it's transferred. So this is an important piece in our assembly. Okay, so the next piece, which is going to be the part that we're translating the motion or rotation to the next part, is the yoke female. So we've done insert components, and we've used the window E key to bring up the file properties. Let's look at another way that we can do this to bring in a part. Another way to do this is to actually open the part that we want to bring in. So I'm going to go to File, Open, and then I want to open up the yoke female. Okay, so I'm just going to open this. Okay. This is actually a way that when you're working on assemblies, this is how I do it a lot of the times, is that I have my part open that I know I'm going to bring into the assembly and the assembly right next to each other, so I can work on both at the same time. So the way we do this is that we go up to the Windows. So if you don't see the drop-down menu, just bring your select tool over the SolidWorks logo, and then go all the way over to the right and select the push pin, and that just leaves the drop-down menu on all the time. So go up to Window, and then say Tile Vertically, and this is going to open up all the files and align them vertically into multiple windows that we have open in SolidWorks. So we have 3 open presently: the yoke female that we want to bring in, the assembly, and the bracket that we started with. We don't need the bracket anymore, so just go ahead and close this. And then we want to go up to Window, and let's retile this again so we just have the 2 parts. Now we've got the female yoke, and we've got the assembly. So you can work on the part and the assembly at the same time, and then when you're done with your part, you just select the part and you drag it into the screen. Okay, and you can drag it in multiple times if you have multiple parts, multiple copies. Okay, so I only have one. We just need one. So go ahead and close the yoke female, and then just go ahead and restore the window. So now we're using the yoke female. So that's the 3rd way that we can bring in a part. And go ahead and rotate your part over, and then maybe move it over to the side. And we're going to do the exact same thing that we did with the spider and the yoke male, but now we're going to do it with the yoke female. So the first thing we want to do is add a concentric mate. So click on mate, select the inside hole of your yoke female, and then the inside hole of the spider. And then SolidWorks adds a concentric mate after you select the check mark. Okay. So we have the same thing now. We need to place the yoke female and the spider. The spider needs to be exactly in the middle of the yoke female. So we're going to do the width mate again. So we have our standard mates here, and our advanced mate is where the width mate is. So let's go ahead and click on the advanced mates, and then we're going to use the width mate again, and we just have to be consistent. So I'm going to pick for the width this time the yoke female. It's closer to me, so it's a little bit easier. So I'm just going to click on this face and rotate it and pick this face. So I've found the center. Now I need to find the center of my spider. So I'm going to pick this face, rotate, and pick that face. And then SolidWorks automatically places my yoke female and spider centered with each other. So go ahead and click the check mark again, and spacebar isometric. And now I have my yoke female. Okay. So in order for this to work, this face needs to be parallel. This face here needs to be parallel with that face. It's not coincident because it's not long enough. This isn't long enough. Actually, there's a gap. It won't touch. And that's kind of a cool thing in SolidWorks. If you try to make a mate that's not possible, SolidWorks will tell you that's an error. So that's actually good news, because it says, then you can look at like, okay, that's not possible. You know, so it looks like that face can touch, but actually it's not long enough. Okay, so we're going to go up to the Assembly tab again, select Mate, and you're going to pick the bottom face of the yoke female, and then this face of the bracket. And you'll notice that's a parallel. We can't do coincident. If you tried coincident, you would get an error. And then click the check mark. Okay, and then click the check mark again. And then spacebar, isometric. Okay, so now when I rotate this, I can rotate in two different directions. And this is called a differential. Okay. Now, right now, you know these are just mates. This would actually fall apart. You know, it's not possible for that to rotate. We need something that goes in these holes so this will rotate, and that's the pin. So let's use the Windows key, which is between the Control and the Alt, and the letter E to open up our file properties. Let's try that again. So go Windows, E, and we want to find the pin. Okay. Now the pin, the way it was made is that it's actually a part file that's composed of multiple variations of the part. Those are called configurations. So in this case, there's only two. There's a long pin and a short pin. So when you drag the pin in, we're going to get something new. So I'm going to drag the pin in. I'm going to close this. Well, actually, this is frozen, so hold on a second. Okay, so we have two different configurations. So we have a long pin and a short pin. So go ahead, and I want you to go ahead and select the short pin. Okay, and then go ahead, and so this is going to create a smaller pin. Okay, so there's two short pins, or one short pin, but we actually need two of them. So this is a little trick. I don't think it's in your SolidWorks book, but is that we can actually create copies of parts by just dragging off another part. And the way we do that is we hold the Control key down on our keyboard, we select the pin or the part that we want to make a copy, and then you just drag off a part. So now we have two pins. So what I want you to do is I want you to put a pin here and there. So that's going to start off as a concentric mate. Okay, so we're going to maybe move the pin over, rotate the pin a little bit, so it kind of looks like it's going to line up there. and then go ahead and click on Mate, pick the pin surface, and then the hole, and then select the check mark. Now if the pin goes into the hole, you can just drag it out. And so you want to drag this out just a little bit. And now I want to mate this surface with this curved surface. And that is a tangent mate. When you mate a flat surface with a curved surface, that's a tangent mate. So pick the face of the pin, and then the curvature of the yoke female, and then that makes it flush with a tangent mate. So go ahead and click the check mark. And now I want to do the exact same thing. So we're going to rotate this part over. Maybe rotate the pin a little bit. And now you're going to add a mate of the cylinder and the hole. Okay, just make sure if it's inside of the part, just pull it out. And we want access to this face, so go ahead and select that face, and then pick this curved surface. And then check go ahead and click the check mark. Okay, so now we have two pins. So go ahead and click the check mark, and then space bar, isometric. Okay, so we actually need another pin. So there's lots of ways that we can do this. So let's go ahead, and here's our fourth way to bring in a file. So go ahead, and there's also actually a file explorer under the SolidWorks resources. So go ahead and click on the file explorer. And then under desktop, find your file. So mine happens to be under EGR 264. It's on the iDrive for me. And then it's under Fall 17, under Assemblies. And then what we want to do is find the pin. And so what's nice about this is if you move the select tool over any of the files, it actually shows a character or a cartoon version of your part. So you can kind of look at, see what you're working with. So go ahead and click on the pin and then just drag it in. So that's the next way that we can do this. And we get the selected configuration to be used. So what we want to do is we want to go ahead and select the long. Okay, and go ahead and click OK. So now we have a long pin. And so what I want you to do is stick the long pin in this hole. Okay, and so maybe you want to rotate your part so it lines up with the hole in the assembly there. And go ahead and click on Mate. Pick the long pin cylinder surface and pick the hole, not the edge, but the hole cylinder. And now we get a cylindrical mate. I'm sorry, concentric mate. And then let's do a tangent mate by selecting this face and that face. And now we have a tangent mate. Okay, and then click the check mark. So we're almost done. Now this is how this part would actually move. Okay, so we're missing one thing, and that's the handle that fits on the top, and that's the crank arm, crank knob, and I forgot the third part. But let's use the Windows E. Between the Control and the Alt key is the Windows key and the letter E. And go ahead and find your part. Parts are the crankshaft, the crank knob, and the crank arm. So I want you to bring in all of those parts. Okay, so bring in all three parts. So if you can start, what I just did is I picked the first one, held the shift key down, and you can pick multiple parts and drag them in. Okay, so I'm going to close this. So let's just move these around. And so these are the last parts that we want to mate. So there's actually 5 ways that we can create mates, and the way that I showed you how we started, that's the way that you're mostly going to be doing your mates. It's just picking the surfaces and then or edges, and then letting SolidWorks make a recommendation for the mate, and then selecting that mate. There's another way, and this is called advanced mates, but it's not really an advanced mate, it's just a different way of doing this. But what I want you to do is take the crank knob and right click on it and just rotate it up, and then zoom in so that you can see the cylinder of the crank knob and this hole. So we can actually add mates by dragging parts onto other parts. And then SolidWorks looks at the geometry and makes a recommendation for the mate. So the way we do that is you hold the Alt key, it's to the left of the end to right of your space bar, hold the Alt key down, and then select the surface that you want to mate. So I want to select this cylinder, and I'm going to drag it to this hole. So I'm going to hold the Alt key down, select the cylinder, and as I move it, do you see the paper clip? As soon as you see that paper clip, you can drag it to a surface and it will add a concentric mate just based off of the geometry. So go ahead and find the hole and then release. Yep, do I want a concentric? Yes, I do. So click the check mark. And in SolidWorks, all the mates are captured under these two paper clips. So we can edit any of these. They're just like features. Edit the feature, you can make changes. So if we wanted to make a change, we could, or delete the mates. So let's go ahead and delete the last mate, which is the concentric mate. So go to the very end, select it, and then just click delete on your keyboard. And say, yep, I want to delete it. And then let's move your crank knob off again. And then rotate it up. And then there's another thing that we do. If you have, you can do multiple mates at the same time, meaning that I could add this cylindrical mate and a coincident mate at the same time by looking at where they intersect. So the cylinder and this face intersect at this circle. So if I hold the Alt key, so go ahead and hold the Alt key down, and then select the circular edge where the cylinder and the face intersect. Select it, hold the left mouse down, move this around. Let me do that again. Move this around and you'll see paperclip. Now if I drag that over, it automatically adds a concentric and a coincident mate at the same time. Okay, so if I bring this over and then I release. And if you look, it's added concentric and a coincident. You can do all of these mates by dragging parts onto other parts. It takes a little practice, but for go ahead. It's up to you how you want to do this. I think if you're just learning, you're just starting, just do how we started by just doing the mates, picking the cylinder, and then adding the mate. But if you want to try, and if this looks like something you want to do, go ahead and practice. It takes a little getting used to, but it can be super fast once you get it down. Okay, so let's go ahead and select the letter S on our keyboard, and then that brings up the Smart menu, and it's specific to where you are. So if I'm in a part, assembly, or drawing, this is going to change, but here's the paperclip again for mate. And let's go ahead and mate this cylinder with that cylinder. Okay, and we'll finish out our handle here. Now you'll notice that this has a flat surface, and if I rotate this part, this is also flat, and we need that to be able to transfer torque. If this was just a circular hole and circular shaft, there's no way that I could actually apply torque. I need that flat surface. So we're going to mate this face with this face. And you'll notice, so we're going to add a coincident mate. Okay, and then I want this face, because this is where this crank arm sits on. I want to mate that face with this face. Okay, now our crank arm's done, our handle, and now I want to do the same thing. I want to put this handle on top of our yoke mail. Okay, so the first thing is I want to add a concentric mate to this cylinder hole, cylindrical hole, and this cylinder. Okay, and then I also have to add a mate between that face and that face. Okay, so I'm going to go ahead and select this face, and then I'm going to rotate and select that face. Okay, now there's actually a gap between those two for this screw. There's a set screw that goes through there, so that's going to be a parallel mate. So this is concentric, but that face and this face don't actually touch. There's a slight, very small gap. So it can't be coincident like we did before. It has to be parallel. So go ahead and click check mark. And then lastly, I want to mate this face so it sits on top of the bracket. So I'm going to pick this face and click the check mark. And then check mark again, spacebar isometric, and now our part is done. Okay, so we want to save this. So we saved it last time as today, so I'm going to go ahead and click on File, and then Save. I want to rebuild it. That's just good practice. And we called it today, so I'm going to call it today again, and just say Save. Since I already have it, it's asked me to replace it, so I want to say yes. Okay, and then like we did in class, and then I'll go over this again today, is you want to go to Pack and Go, and then do Pack and Go. Okay, so I hope that was helpful. Oh, also always make sure your name is in the file properties. That's important. So say OK, and then save it. And remember, this is a assembly file. It's a database that keeps track of all the parts that you have and all the mates, and that's it. And the visual properties. But in order to see and actually interact and make changes, we have to also include the parts with our assembly, and that's why we use Pack and Go. Okay, so I hope that was helpful.